When a coronal mass ejection forms a complete halo around the sun, it can look like the entire cloud is coming straight at Earth. But that image does not prove it. A halo tells us that much of the eruption is moving along the camera's line of sight. The problem is that a line has two directions, toward the camera or away from it. So how do forecasters tell the difference? This image comes from a coronagraph. Its central disk blocks the brilliant surface of the sun, so the much fainter corona can be seen. The CME is a three-dimensional cloud, but the camera records a flat, two-dimensional projection. If a wide cloud travels toward the camera, its outer edge can appear to expand around the occulting disk. But a cloud traveling away, on the far side of the sun, can produce a very similar ring. From this view alone, depth has been compressed out of the picture. The first clue comes from finding where the eruption began. Extreme ultraviolet images can show a flare, an expanding wave, or dim regions where coronal material has been removed. If those changes appear on the Earth-facing disk, the halo has a front-side source. If there is no matching front-side eruption, and another spacecraft sees activity on the far side, the halo may be traveling away. No single bright patch settles the case. Forecasters compare the timing and location of several signatures. SOHO observes from near the Sun-Earth line. Stereo A views the sun from a different position. An eruption that looks like a ring from one camera can look more like a cloud moving sideways from another. Combining those views helps estimate the CME's width, speed, and direction. Forecasters then use those measurements in propagation models to calculate a possible arrival window at Earth. That window is a forecast, not an appointment. Now return to 3rd October 2024. An X9.0 flare erupted from NOAA active region 3842, close to the center of the Earth-facing solar disk. It began at 12:08 UTC, peaked at 12:18, and ended at 12:27. At 12:48, a CME appeared as a full halo in SOHO's coronagraph. But the halo was only the first clue. The central front-side source, extreme ultraviolet wave and dimming signatures, radio observations, and an additional stereo A view together supported an Earth-going component. Research analyses placed its likely arrival around 5 to 6 October. At 6:55 UTC on 6 October, spacecraft near Earth measured a shock. The event analysis linked it to the 3rd October eruption, while noting that earlier CMEs may also have been swept into the arriving front. That is stronger evidence than the halo image alone. Source, multiple observations, a modeled window, and finally, an in situ measurement. Even then, one crucial piece remains hidden. Coronagraphs cannot reveal the exact magnetic field direction inside an approaching CME. That field is measured only when the structure reaches spacecraft upstream of Earth. Its orientation matters because a sustained southward field can connect efficiently with Earth's magnetic field and drive a stronger geomagnetic storm. So, likely Earth-directed does not mean storm strength confirmed. Direction, arrival time, and magnetic impact are three different forecast questions. Is a halo CME really heading toward Earth? The honest answer is not from the halo image alone. A halo is an important clue. Confidence comes from the source location, on-disk changes, radio evidence, additional viewpoints, models, and finally, measurements near Earth. That is the forecast ladder: apparent, likely, modeled, then observed. For the difference between the flare and the CME, watch episode 2 and subscribe for the next part of Solar Storm Explained.